Hello everyone, my name is Naveen Kumar and I'm faculty of physics at Rawat Public School. Now today we will learn about the chapter 3 of the class 11, that is motion in straight line. Okay, this is the third chapter of 11th class. Now in our daily life we see various activities, various things, just like as a moving object, car is moving, okay, a ball is falling down, okay, a baby is crawling, okay. So all these examples, in all these examples, object is moving, okay. So simply we can say that change in the position of an object can be considered as the motion. Okay, so let us discuss the first term. It can be seen as change in the position of an object, but we modified this equation and this equation become change in the position of an object with respect to time and surrounding. Change in the position of the object with respect to time and surrounding is motion. Okay, so it is a state. So the state है वो दो टाइप के हो सकते हैं. It can be rest or it can be motion. Okay, so object is at rest means object is not changing its position with respect to time and surrounding. Okay, and how we come to know that object is changing? Let's suppose here is an object. Okay, this is at the beginning of this drawing. Now after some time, if you find this object is at this point, now we can see here that initially the position of the object was the beginning of this diagram. Okay, now after some time, at the end of our observation, we found that object is at some different location. That means surrounding of the object is changed. That means this object was in the motion during that time. Okay, the time has changed and surrounding has changed. So we can say the object is in motion. There are different kind of motion of the object. So let us understand that various kind of objects, types of motion. Now, first type of motion is rectilinear or translatory motion. Translatory motion. Now, see, both the things are quite similar. Okay, rectilinear motion and translatory motion, these are quite similar. There is only a small difference. Rectilinear motion, we will call this thing in case of point object. Okay, and this translatory motion is in the case when the object is not point. And this was in the case of point mass object. That means when the object was very small, in that condition we can motion of the object, we can say that is the rectilinear, or when the object is not point mass object, then we can say that object is in translatory motion. Okay, now this rectilinear motion we can define here the motion of the object if it is a point mass object in a straight line. Okay, now translatory motion, if the object is not a point mass, in that condition if object is moving, then all the particles of this object are having same speed. Okay, so if the particles, constituent particles are having same speed, that means we can say that object is in translatory motion, and if it is moving in a straight line, okay, then object can be considered as translatory motion. Now second type of motion is circular or rotatory. Now circular motion and rotatory motion, again the same thing. This can be defined if object is point mass object, and this rotatory motion can be defined when the object is not point mass. Okay, so circular motion is a motion of a point mass object if the object is covering a circular path, that is of motion in circle. Now if the object is not point mass object, then the motion of the object in the circle and all the constituent particles are moving and making a line as the center, or we can say it is a axis. Okay, now third type of motion, I'm erasing this one. The third type of motion is oscillatory or vibratory. Now oscillatory motion, that means to and fro motion, to and fro motion of the object, and to and fro motion object is under oscillatory motion, and if the magnitude of this oscillation is very small, then we can say that object is in vibratory motion or vibrating. Okay, I hope it is clear to everyone about the three motions. Now we are seeing a point mass object, so let us understand what is that point mass object is. Point mass, body or the object. Okay, now an object is considered as the point mass object if it covers a very large distance as compared to the size of the object. Okay, very large distance as compared to size of the object. Now for example, let's say earth revolves around sun. Okay, now let's suppose this is the sun and earth revolves around it. Now you can see here the diameter of earth is very small as compared to the size of this orbit in which the earth is revolving around the sun. So in this condition we can say that this earth is a point mass object. Similarly, a car is moving from one city to another city. Now distance of city, if the distance is very large as compared to the size of that car, then we can say that car is a point mass object. But we cannot consider car as a point mass object in that condition if car is moving from your home to a nearby shop. Okay, that means if the distance covered by the car is very small, then we cannot consider the car as point mass object. Now let us understand the next topic, motion. In 1 dimension, 2 dimension and 3 dimension. Now first 1 dimension, when we can say the motion is 1 dimension. Okay, if the one of the coordinate of the object, now motion is can be considered as 1 dimensional if one of the three coordinates which are specifying the position of the object are changing with the time, then we can say that the object is in one dimension. That means a straight line motion, basically straight line, just like this one. Object is here, then after some time it is here. So only one coordinate which is specifying the position of the object out of three coordinates, if it is changing, then we can say object is in one dimensional motion. Now second thing is two dimensional motion. Two dimensional motion means if the two of the coordinates out of three which are specifying the position of the object are changing, then we can say the motion is in two dimension. Let's say this is the y-axis, this is x-axis, and the object is here, x-y coordinates. Now you can see in this diagram the two coordinates of the object, this x-y axis, are specifying the position of this object. Now after some time, if the position is here, that means x2, y2. Now both the coordinates are changed. That means two coordinates are changing which are specifying the position of the object. Such kind of motion is known as two-dimensional motion. Now third one is three-dimensional. Now three-dimensional, if all the three coordinates which are specifying the position of the object are changing with time, then we can say it is a three-dimensional motion. The position of the object with respect to x-axis, y-axis and z-axis is changing with respect to time. So in the next video we will learn about more terminologies of motion in straight line. Thank you very much.